Good afternoon, everyone. We are waiting 1 or 2 minutes for everyone to connect. Well, I will start with the introduction. Thank you for joining us today. We are excited to have you here for our webinar on Master Reverse Engineering with PL3D. My name is Maria Fortes, and I will be one of your hosts for this session. Before we dive into the content, let's go over a few housekeeping items. This webinar will last approximately 1 hour. We will have a Q&A session at the end, so please feel free to submit your questions in the chat box through the presentation. A recording of this webinar will be available after the session. I would like to introduce you to my colleague Marcio and Joe Winston from the company MSL, who will be sharing their expertise with us today. Let's get started.
Hello guys, my name is Marcio Knapik. I'm an engineer with over 12 years of experience at Creaform PO, specializing in 3D scanners. So throughout my career, I have had the opportunity to work in various roles, starting as application engineer for 8 years, then moving into technical support, and then for the past 3 years, I have been working as a sales engineer. So in my current role, I combine my technical expertise with deep understanding of customer needs to provide tailored solutions that drive success. I'm excited to share my insights and the experiences with you today. So thank you for your attention, and then I will let Joe introduce himself.
Thank you, Marcio. My name's Joe from Measurement Solutions in the UK. So it's Measurement Solutions. We are the UK reseller for Peel. So I started in the 3D scanning world, actually came here from 3D printing. So I've been with Measurement Solutions for about 3 years now. Before that, did a lot in the world of 3D printing. So it's quite a nice link between 3D printing and 3D scanning. That's how I found myself at Measurement Solutions. So we'll get into a bit more detail of MSL and Peel just shortly. So if you can skip to the next slide for us, Marcio. Just to go through a quick agenda of what we plan to cover off today. So first off, we'll go through a quick introduction of Peel3 and Peel.cad. We'll go into some application examples, so some real world use cases of Peel. Marcio is going to take you through a live demo of Peel3 and Peel3 CAD. So we'll show you Peel3 in action, scanning, and how we take that scan data through the CAD software as well. And then at the end, we'll go through a Q&A session. If you've got any questions throughout the session, then raise your hand, drop your question down. We'll try and pick those up at the end for you. Okay, so quick introduction and kind of how we got here, I guess. So Peel and Creaform are part of the same family, all Canadian designed and manufactured, and the Canadian element is a really important bit for IP, and especially when dealing with contracts within MOD, things like that here in the UK. We're seeing a lot of clauses to stipulate no Chinese components in 3D scanners, and with Peel and Creaform, we're one of the only companies that can say that we don't have any Chinese componentry in our systems. So Creaform was founded over 20 years ago now, and they built their first handheld scanner in 2007. Not just Creaform's first handheld scanner, but the first handheld scanner to be made was by Creaform in 2007, and it was really revolutionary back then. We went from engineers having to cart around large infrastructure with cameras and alignments. Now they could just walk up to a part with a handheld scanner and create the 3D scan. So since then, Careerform have really been at the forefront of development in both hardware and in software, which we'll cover a little bit later. So fast forward to 2017, and Peel was launched. Peel is all about accessibility. So it was a spin-off from Careerform, and the accessibility is aimed at price. So having a price point that is accessible, and user experience as well, making the hardware and the software as simple to use and pick up as possible. So as someone who's never scanned before, pick up the scanner and start to 3D scan straight away. So the huge advantage that Peel had over its competitors when it started in 2017 was that they had 15 years worth of experience with Careerform, scanning experience, technology, knowledge, access to patents. So a massive array of knowledge and information to fall back on. In 2022, Peel released the Peel 3, which is a completely redesigned scanner. I think the video playable, Marcio? Run that on the screen.
I'm sorry.
No worries if you can't get it to go.
The video.
No worries. It was only just something to go in the background anyway. So the Peel 3 redesigned in 22, and the ergonomics were completely redesigned. So the Peel 1 and Peel 2 were based on some old Careerform technology. Peel 3 was redesigned kind of from the ground up. So the ergonomic handle makes it easy to hold in a horizontal and vertical, an LCD screen on the back to help you out while you're scanning. And also improvements in speed and accuracy, again, tapping into what's now 20 years worth of Careerform's experience with scanning. So Peel uses white light technology. The top and the bottom cameras that we can see here are used to scan or pick up surface and geometry. There is a infrared projector in the middle here, surrounded by a ring of LED lights. The infrared projectors above. The camera in the center here picks up color and texture, and a ring of LED lights, which will automatically adjust to whether you're scanning dark surfaces, which absorb light, so you need a more powerful light source, and brighter surfaces, which reflect light, you need less light for those. That will automatically adjust. And above, we have the infrared projector. So that's going to project out a series of grid lines, which will the cameras at the top and bottom will use to pick up the part. And with white light, we get a massively versatile scanner. So like I said, we can scan color and texture, which is great for things like scanning for virtual reality and augmented reality environments, as well as scanning things like artifacts to make digital twins of heritage parts, artifacts, things like that. So we talked quite a lot about the hardware. The software is hugely important. You can't really overestimate the importance of the software with the scanners. You can have a £100,000 scanner, but without the software to take that sort of dumb STL file through to a usable file, your scan data is useless. Peel and Careerform are both constantly working on the software, bringing out new updates, new tools, which Marcio is going to cover for you a little bit later in the live demo. One of the main features is the ability to transfer straight into your CAD packages. So Fusion, SolidWorks, once you've created your entities, sketches, features in peel.cad, click a button and you can transfer those into your CAD package. So as MSL, where do we really fit into all this? Careerform and Peel are based in Canada, so it's quite important to have a UK presence, feet on the ground here in the UK, and that's for the full sales cycle. So from the start, doing demos, exhibitions, shows, things like that, we need people in the UK. Also for after sales, having application engineers here in the UK on the same time zone for things like training, customer support, emergency repairs, things like that. That's why it's important to have us as a partner in the UK. So MSL, we were founded in 1998, and started off the business mainly focused on CMMs, so calibration, service, and maintenance. So we've got years and years of metrology experience at MSL. 2007, when Creaform launched the first handheld scanner, was when MSL partnered with Creaform. Back then, we were one of a few partners in the UK. Since then, we're now the exclusive partner in the UK, so the sole reseller in the UK. And since that time, we've put over 3,000 Creaform installations in the UK, and that's across around about 700 customers over here in the UK. And that's anything from entry-level scanners right through to £200,000 worth of multi-camera system automated robotic scanners, and used in a huge variety of industries, from Formula One, clay models for automotive companies. We've got scanners in the MOD, aerospace applications, universities, colleges, medical applications, a real broad spectrum of different industries and applications. So I think that probably covers most of what we wanted to touch on in the intro. We're going to look at some practical examples now of reverse engineering and metrology workflows, which Marcio is going to take us through, and then we'll get on to a few different industries that we work in Peel. So over to you, Marcio.
Thank you, Joe. So right now I will show you guys some typical examples of usage of the scanner. So first one, it's a typical workflow where we're gonna use the scanner and then we will do scan and reverse engineering process. So at the beginning, we're gonna start by scanning the physical part. So it's the first picture where the guy is holding the scanner. So the device captures the precise geometry of the object and then creating a detailed 3D digital representation. So it's the second part here where we can see all the mesh created by the scanner. So after the scanning, we will use the software Peel.CAD, which is the module that comes with the scanner. And then to clean the mesh first, and then cleaning the mesh and then creating the geometries. So this involves removing any noise or unnecessary data from the scan. So as you can see, all that the scanner will acquire more data. Anything that he can see on his side of scene is going to be scanned. So it's why we have to do this cleaning before to start extracting the important geometries. So then this is the third part. So it's where we're gonna use the Peel.CAD tools. After the scanning, we use Peel.CAD software for cleaning and then extracting the important geometry. So it's like we are creating those geometries and measurements, critical features needed for the next step. So the next step, once we got all the information, all the geometries we needed, the dimensions we needed, then we can export to CAD software. So such as SolidWorks, Fusion, Inventor, Creo, any software, any CAD software that can import IGS or step file can be used. So then it's where we're gonna extract the geometry and creating a precise digital replica of the original part, which can be used for various applications, including manufacturing and or quality control. So that's one of the typical process where we will use the scanner, Peel.CAD to create geometries, and then send all those geometries to the CAD softwares for to create your solid model. Guys, let me know if you have any questions about this slide. You can chat, send your questions to Maria, and then don't worry, go ahead and ask anything. So we will go to the next slide. So the next slide, it's more to, we can use the scanner as well to take the measurements. So taking the measurements, because we need those measurements to fit a new part on it. So then it's a similar, we're gonna start the project similar to a reverse engineering process, where we start by scanning the part with the Peel 3D scanner, and then to capture the geometry of it. Then again, we will clean the mesh, and start by cleaning, because some of the data we don't use, we don't want it, and then uh, extract the import geometries extracted by using peel.cad. So this is going to ensure the accuracy on the measurements. So measurements is taken, and then we can use this STL. Once we get this reverse engineering done, so we have the part done, we can use save the STL file, which is a common format for 3D models. This STL file, it's used to check for any interference to verify dimensions. So ensuring that the part fits correctly in this intended application. So design the new part right over the STL, and then you can design the part on your favorite CAD software. So finally, we'll design the part directly over the STL file, and this allows for precise alignment, integration, which is with the existing part. So those are typical examples where we can use the scanner and Peel.cad to extract all the dimensions, all the important features and geometries to create our solid model. So the next slide, Joe will give you some more examples. So we'll let you, Joe, continue with the examples.
Thank you, Marcio. So I talked a bit about the versatility of the scanner and multiple use cases across various different applications industries. So we're just going to touch on some of those in a little bit more detail. For some of you guys, this might be industries that you're working in already, and some it might just be kind of an inspiration for use cases that you can use for the scanner. So aftermarket automotive, probably one of, if not the biggest use case for Peel scanners, and a few different kind of subcategories within here, bodyworks, scanning broken mechanical parts to create new parts, also interiors and upholsteries. Customization of vans and trucks, so fitting out camper vans or delivery vans with bespoke storage or camper solutions. So creating the digital twin can really help here with the design. And older vans or older vehicles in general, there's lots of inconsistencies between one car and the next car. So having a digital scan of each individual car is really useful there. Aftermarket motorcycle, kind of similar again to the automotive aftermarket, scanning for bodywork and mechanical parts. Heavy industries, again, old, worn or damaged parts that you can scan, bring into CAD to repair, create models to repair older parts. And the next slide goes into castings, large parts and molds. So we can kind of group a lot of these together. These can be used for inspection purposes, like we just saw in the previous slide from Marcio. Again, having digital twins of kind of large parts for AR and VR environments is quite useful. Design-wise, within the software, we can create a scan and then flatten that scan to create a 2D version of that to wrap around something. So good for furniture design, for upholstery, also for things like graphics and vinyls. Customized foam cases. So if we're creating foam cases for specific parts, individual parts, we can scan that part, create a silhouette in peel.cad, directly import that silhouette straight out to Fusion, SolidWorks, whatever your CAD package is, and use that to create your cutouts for your foam cases. Product design, again, prototyping and creating digital twins. Heritage and preservation, we've seen a project at MSL. We worked with the National History Museum where they wanted to create a sort of a digital inventory of all of their artifacts. It's kind of taken years and years worth of scanning, but they're just about now at a point where all of their artifacts are now digitally stored. So if they are ever kind of lost or damaged, there is a record of what they had there. Next slide. I think there's one more left to these applications. Oh, there's a couple more. Architectural, so similar to what we previously discussed. Art, so digitalizing a handmade piece of art. Obviously, there's no CAD model of that before it's made. It's just made by an artist by hand. So creating digital versions of that. Digital twins and CFD analysis. So for aerodynamics, wind tunnel, creating scans, bringing those scans into some CFD software. Healthcare, so orthotics, prosthetics, scanning of patients and creating bespoke products for them, whether that's through 3D printing or another way. Similar for veterinary purposes, so scanning animals and creating bespoke orthotics or prosthetics for animals. There's a specific case study on surfboards and stand-up paddleboards, which is available on the website, and 3D printing, so something kind of very close to home for me. And there's a couple of kind of different workflows here, either scanning a part to create a 3D printed version of it. So within the software, when we do it on peel.cad, we can scan and set it to automatically create a watertight mesh for us that we can send straight to 3D printing. So a part like this, a bracket, you can 3D scan, send straight to 3D print. Maybe with the STL model, you want to do some optimization. So we can run some topology optimization and create an optimized version of this part. We could then scan this part and use the scan data for inspection, maybe overlay it with the original STL or create some points to take measurements. We can do this part here. So this is a scan of a bucket seat. We took the scan, did some optimization to create a lattice structure on that. Again, a few different use cases of 3D printing there. So we'll get into the actual demo of the part. It's probably what most of you are here to see. So I will hand over to Marcio and he will show you what the peel and peel.cad can do.
Thank you, Joe. So right now I will start by sharing my screen with you guys. Again, here I will be sharing, this is our software, peel.os. So it's where we're gonna start by our scanning process. We will start by here, where we can see there is a new button, so new scan button, and then all the different projects you can be working on. So software, it's a new software. It was developed in 2022. So it's we try to streamline the process to make it easier for any new customer. So when we are ready to start scanning, we just need to press here the next step. So it's a step-by-step where the software will guiding you through all these steps during the acquisition and the post-processing. We'll click here on the next step, and then we will starting by the parameters windows, and then it's where we define the size of the object. If you have a really small object to scan, we can use the tiny. Small, it's for a size, let's say a size of a helmet. A medium size, something like see, and then large scans, we could be scanning a entire car. So I will share another camera as well. So I will show you guys what I will be scanning today. So this is a casting, and then I have here the scanner as well. So this part we don't have small details on it. So I will scanning with maybe a small, and I will define here my geometry, my resolution as 1 millimeter. So even though I don't have uh, very small details on this part, I would like to show you the how the scanner can acquire these small features and show you the details on. So once we define the size of the object, the detail, the smallest detail on the part, we have the output parameters where we can define, use the different ones. It's more, this is going to clean the mesh and remove some spikes. So normally for reverse engineering or even for, let's say, quality control, we will use more express and balance it. For 3D printing, we can use the enhanced or the watertight. So the watertight will create a file that there's no holes on. So it's really useful for when you want to 3D print using the STL as is. Software is able as well to capture the color. So as John mentioned before, we have two cameras here. So these two cameras are acquiring the geometry of the part. And then we have this center camera where it's acquiring the color of it. So if you have a part that you want to scan, you want to capture the color, then it's going to be this camera that will be seeing that color on the part. So for the color, we have as well different options for the quality of the resolution. So low res, and then we have as well the custom resolution where you can define exactly what is the size that you want to use. So right now, I will, once this is defined, I will go to next step. So we could just click on next step here or go here on the top and then go to the scan. So here on the scanning, we have a couple of buttons where we can start our scan, calibrate the scanner, uh, uh, do a rewind, so some options while you are scanning. And on the scanner as well, we have a display. So multiple of those tools are available as well on the display, so you don't need to go back to your computer all the time. So for now, I will be starting our scan. So I will just click here, start, and then you can see it's a real-time 3D scanning, parts being acquired. So you can maybe asking why the part needs to be stable, needs to be in a in a table like where there's no movement. But because we are using those small targets, those points that you can see on the display, so the green ones, the green uh, or white targets. So those targets allow us to move the part while we are scanning. So there's not like a CMM where the part must be uh, in a same position all the time. So this can be moving while we are doing our scanning. So then you just need to go around the part here. The scanner are reading those positioning targets, and then the cameras are reading the positioning targets and reading at the same time the deformation of those lines, creating the 3D model. So different angles, we can hold the scanner in vertical position, we can scan holding it on horizontal position as well. So there's the scanner will be acquiring the data all the time. So we try to make a good scan here, even though we don't have too much time. So let's try to do the best scan we can. Any question, Maria? Just let me know.
No, we don't have any questions yet.
So I'm almost finishing the scan, and then and
Just
then
while you're just while you're finishing off that scan, Marcio, I would just talk about the different colors that we can see on the screen. So there's a specific standoff distance between the scanner and the part that we want to be scanning. So you can see those green lines. Those green lines mean that we're the correct distance away from the part. We're picking up data there. You can see some of the targets have gone blue and some of the lines are going blue. That means we're too far away. So again, working to making scanning as accessible and easy as possible. It's color coded, and you'll also get some haptic feedback on the scanner when the scanner isn't the right distance away. And you can see Marcio's now a bit too close to the part. Those lines are going to turn red to indicate that you're too close, and the feedback you're going to get some haptic feedback on the scanner as well. On the LCD screen on the back of the scanner, you'll also have some indication here of whether you're too far away, too close to the part, and if you lose tracking, if you can't see enough of the tracking targets to do the scan that you're doing at the moment.
so maybe one of the questions will be, can I scan the bottom of this part right now? Because we will not have the bottom of it. So we could. It's something that is possible on the software. So we will stop the scan and then flip the part and just start a new scan with the part flipped. So it's something that it's possible as well. Um, so once we think we get done with this, all the data, we can uh, take a look around with the part and then see if all the details or if you have everything you want, you need to measure this part to create the geometries. So if you think it's all we needed, we can go to the next step. That's gonna be the cleaning. So I will go to the next, and then uh, here it's grayed out, but you'll be seeing right now we are on the cleaning step, where by default the software will try to find one a cutoff plane, but we can sometimes it's not accurate, so we can uh, define by ourselves the plane that we want to use. So, or the second option, it's just using the arrow here to go up and down uh, with the plane. So that I think I can use this as is. So all that data, all that red data will be deleted by the software. So if I click here, continue, then the software will delete that red selection. So we will get rid of these points. So in the case that we want to flip the part and scan in the bottom, so we could do that. We can add a new scan. So we'll move this to here. So we have the options to add a new scan, or if we already have that scanned data done in another session, we have as well the option to import the scan. in this part. So let's do a quick import of the scan, create a new scan, and then I will flip the part here, and we will do a quick scan on the bottom. So this first scan will be kept on the memory of the part. So we have here scan one. So this is going to be the scan one, and then once the data is processed, we will have the scan two to start our second scan.
I got a question that maybe you can answer in the meantime. What is the smallest object that can be scanned?
The smallest object is let's say for a pin we have 1.5 millimeter. For a hole we have the smallest hole we can scan it's 3 millimeters. If we have a step, so a step, if we have two planes and we have this step between those two planes, the smallest step will be zero point 0.1 millimeter, and then if you have a wall thickness, the smallest one will be 1 millimeter.
Mhm. And there is another question from one participant. How far away are the targets?
The targets we can apply it randomly on the part. So if it's a flat part, we can it's between 1 and 4 inches the distance. When it's a flat part, we can use more. It's going to be more 4 inches. But when you have curvatures, then we can apply the targets closely. To mention something as well, it's the scanner works with the targets, but can work as well without the targets, as long as we have geometries on the part. So when the, the when the light is projected on the part, and we have deformation on that light projected, then the scanner can use as well this information to get his tracking. So not all the time we will need the targets. We will need the targets most when you have flat surfaces. Then then we must apply the targets on.
Okay,
So
thank
right
you,
now
Marcio, for the clarification.
I'm ready to start the second part. So I will click here on, oops, sorry. I'll click here, and then we can start the bottom. So I will not do the entire process with you guys today right now because it's gonna take too much time for it. I think we can. It's just to show you how easy it is uh, to combine two different sections of skin. Here, skin the inside. Most of the most of the part was scanning in the first scan, but then we just get some of the less scanned, and then show you guys how we can use the merge to combine two parts.
This is where we talked earlier about the importance of the software. Being able to scan these two individual parts is one thing, but you could spend hours trying to manually merge and align these two scan data back together in the end to create the full part that you're after at the end. But once Marcio's finished this second scan, you'll see how easy the software will just lock these two scans together, and you're going to have that full part straight away.
I think that's enough, and then let's go again to the similar step here. Will be to the next on the cleaning.
We got another question. How much difference is there in performance between the old pill scanners model and the current one?
Do you wanna take that, Joe?
I haven't actually used the old one myself, so I've only got the PL3 as a baseline. Um, so probably not the best person to answer it. Have you?
What was the question, Maria? I didn't hear very
How
well.
much difference is there in performance between the old pill scanner model and the current one?
Okay. Yeah, the old pill scanner, it was acquiring 550,000 measures per second. This one here, it's 1,250,000 measurements per second. So the first thing it's on the how fast we can scan with the scanner. So it's almost 3 times faster than the previous version. We are better on the accuracy as well. So this scanner it's more accurate. And then the mesh resolution, it's with the P3, it's better. So we can that means we can scan small details with the scan the P3. So then after that we have the new software where this guided workflow, and yep, this is basically the I think the highlighted features from the DPU3.
Okay, thank you, Marcio.
So here, as you can see right now, we have a new step. So it's the merge. And then when we're gonna go to the, we'll send to the next step here, the software will try to find the common points to align the two scans. So as John mentioned, alignment can be very hard and can be very time consuming. So the software here makes our life easier because he find automatically the common points. So those red targets are the common points between the two scans. So it does align the two scans, and then we can go to the next. Once we think this alignment it's okay, so we can click here and accept the alignment. So now all the two scans are now locked. So that means they cannot move anymore. And we could add a new scan if we have a third scan of it, or we can go to the next step, which will be um, the peel.cat. So we have this message. Once you scan two scans in only one session, then on the merge step, they will be merge it together, and we will have at the end we will have only one scan. So I will accept, and then right now the software is computing and creating that one file. So you don't need to think about the alignment. It's software it's doing by for you, and then it's creating these the mesh file. Right now I think it's gonna be a good time, Maria, if we have
Um,
another
Yes,
question.
we have two questions. The first one is it possible to merge multiple scans? So more
Yeah,
than two?
exactly. Yeah. So in the case here, we have a third scan. We could be we could click here on the add a new scan. So we can add 3, 4, 5 scans, and then merge them all together using the merge tool. So yeah, it's possible to do it. And if you are using common targets, the software will find the alignment automatically. If you don't have common targets, let's say part's too small, we cannot place the targets on the part, then we have other options to do a manual alignment using common points common surfaces in between these scans. So right now it's finalizing, and we wait for the finalization. But for the peel.cad part of the web demo, I will use another part. Um, this here it's too complex to for what I would like to show you guys. So I will use another part that I have prepared for the webinar. So once this is done, I will show you the results of the merge, but then we're gonna work with another small part for the peel.cad portion. So now it's where it takes more of your computer power, because it's merging all this, doing all these calculations to merge the two scan data.
We have also another question. Wait a moment. I need to find it. Can you merge scans together with different parameters? For example, small holes with high tolerances on a large object with no so important surfaces?
Um, no, that's not possible. Once the merge is done, the software will take one of the resolutions you are using. But in the software, we have an option. It's called, I can go back and show you once this is done. We have an option that it called smart resolution. So that smart resolution means if you are scanning, let's say, in 0.5 in 2 millimeters resolution. So the entire surface will be scanned at 2 millimeters. But when this option is it's activated, the smart resolution, in in the geometry and the curves, the software can add more triangles. So it could be up to 4 times this uh, the initial resolution. So you can ending up having 2 millimeters resolution on the flat parts, on the, let's say, if it's a door, and then on the curvatures we can have up to zero point 0.5 millimeters. So that's something that it can be used, and then once this finalization here it's done, I think I used this on this to scan this part, so I can show you the differences on the mesh resolutions. So I think the best compromise is to using this scanning using the smart resolution activated.
And you could also manually apply that as well. So if you know that there are large flat surfaces with really high triangle density, you could select that surface and manually decimate that mesh to reduce the file size as well. The smart resolution is good because it just does it as you go, does it automatically for you. But there are options to do that manually as well.
Exactly. Yeah.
Um, can you, Marcio, speak a little bit on converting the scanning to the CAD model at the end of the demo?
Yeah, yeah, we're gonna go through these steps. So here, it's this smart resolution was activated. So you can see here the differences of the sizes of the triangles. So here we have a high density, so with smallest triangles, and then here on the flat surfaces, triangles are bigger. So that means we optimize the size of the mesh uh, using this smart resolution tool. So for now, I will open another session to work on this on the peel.cat. So just give me 1 second, uh, make it easier. So open another file here. Not save. So right now I have this other part. So something that it's an actuator, and if we go through the steps here for the reverse engineering of this part, uh, when we scan something, the coordinate system is not being it's not being on the part, so it's going to be on the scanner. So the first position on the scanner will create this uh, the alignment for the part. So first thing is to what do we have to do? It's creating the entities for the alignment. So I will be starting by creating two planes. So this will be my plane one. So just selecting just one click on the mesh, it's best fitted when a plane using that selection here that was made. So we'll do plane one, and then I will do the same thing for plane two, but at that time I will add a constraint on my plane. So this plane number two will be uh, perfect parallel to the plane one. So I'm forcing it to be parallel to the plane one. I will click here accept, and then we will create a middle plane just to make it if the part I want to do a symmetrical part, so it's going to be a symmetric plane, and then I will call this plane here uh, middle plane. So for the middle plane I will use the construction method, and then we'll do average plane between the plane 1 and plane 2. So this will create here our first, our second, third plane, and it's a middle plane between the plane 1 and plane 2. So we can enlarge the plane, make it bigger, and then accept this plane. So that I will use this middle plane as my first entity for my alignment. Then what I will do, I will create a middle point here at the center of the part. So how I can do this, I will use the circle. For the circle, we will need, first thing is to define the constraint plane. So I will use the middle plane to as my constraint, and then I will select the circle. So first plane point, and then I will do the same thing for the back cylinder here, creating another point. So then I will change here to a point entity, and this only point entity will create average point selection, which will be the middle point between the circle 1 and circle 2. So right now I have all the entities to create my alignment. And the alignment is very important as well for the post-processing on your CAD software. So right now, if I use this XYZ views, it's not aligned. It's why it's important as well to create the alignment. So we have multiple options to align the part, and I will use here the manual alignment, so the first two, and then we will define the entities to constrain the part. So my middle plane will be locking some axes. So I will choose here plane X and Y. Right now, my offset it's locked on the Z-axis, and the two angles, the two rotations are locked as well in X and Y. So the other features will lock these other points. So origin XY. So right now we have perfectly aligned at the center of the part, and then I will use one of the circles to lock the remaining degree of freedom. So right now everything is locked, parts aligned, and then we can use the different views to see the part. That's the. So once it's done, then we can start to creating the measurements, or what are we gonna use to in or reverse engineering. So I will hide the entities, and then this is something that it's hard to measure with the normal tools, but with the scanner, it's really easy. This surface here, the curvature of this surface. So the tool we can use to extract that is the cross section. So we're using a cross section, and then I will use one of the planes. Oops, that's not the plane I want to use. So use one of the planes to create. So this is, we'll do a cross section, so a transversal cross on the part, and then create those lines which can be used as reference for our in our CAD software. So we'll move a little bit more here towards the end of the part, where I don't have this. So let's keep this way. So we'll have 4 lines, and once I accept this, it's going to create those lines. So we can see the curves. So I have only one. I used this method to create one cross section, but we have other options to create multiple cross sections, or for the entire mesh. So we can accept, and then I will show you on the entities the cross section. So that's going to be really useful when you have to use the drawing tools on your CAD software. So you're going to use these lines as baseline to as reference to draw the part. So we could be using cross sections, and let's say for this part here as well. So let's create another cross section, and then for this one we can use our middle plane. So we can use the entire cross section, or We can do it for the entire part or just for a small portion as well. So if we don't need to have all the part, we can use only a section of the tool to extract the cross section. So the software can be used to extract all these entities, alignments, but can be used as well for a measuring tool, right? So when I was creating those circles, I didn't show you, but we can see here we have the diameter and his position on the space. So for the circle 2 as well. So we have the measurements of the part using the scan. So once you have all these entities created, then with the software we have the option to right click and transfer to SolidWorks. So it's the auto transferring. It's gonna open SolidWorks and import all these different entities. There is the auto transferring works with Fusion 360, Inventor, and Solid Edge as well. So because I have only SolidWorks on my computer, the SolidWorks only SolidWorks it's available. But if you have the Fusion, it's gonna work as well. So it's transferring only the entities, but it's possible as well to transfer the mesh file. So it's the same button, and the mesh file will be transferred.
I
So on
have
the
one question in the meantime. Um, what is the difference between middle plan and average plan?
middle plan and average plan,
Yes.
it's the same. It's the average. It's the average between two planes. So software will have all these. Let's say you have two planes, and then creating an average between all the data inside of those two planes. And middle plane, it's the same. It's the same thing.
Hmm. Okay, thank you. And if you have a hole with 3 millimeters diameter, how deep is it possible to scan?
Um, I don't have the precise answer for this question because if we have to, depends on the part, and if we have access, it's the hole. It's on a flat plane uh, with anything around that the two cameras can see. I think it will be something about 2 or 3 millimeters inside of the hole. But if you have a small hole in a 3 millimeters, then you can add a pin on the hole, and then instead to scan the hole, you scan the pin. So that's gonna give you as well um, the center point of the hole. So I'm sorry. So this is my file. Open it in SolidWorks, and then you can start to build your part using those lines as reference. So this is Peel.cat. It's where you prepare, you take measurements, and then you send those measurements references to your CAD software, and then from there you start rebuild your part, creating your solid using these sketch tools. So we are, on this webinar, we will not go through the process of creating the entire part, but it's something that you can, uh, we can do it using the CAD tools here. So, sorry. For example, create a circle, and it's where you have more tools to, let's say here we have a circle of 12, 6, 1. We can adjust the size and adjust the lines over the cross sections that we have created on Pio.cat. So as I mentioned, we don't have the time to do all the process, all the reverse engineering process. It's going to take a bit more time, but I think you can have a good idea on how to work, how the Pio.os, so the scanning module, and then Pio.cat works in conjunction with the CAD softwares such as SolidWorks, Inventor, Fusion. I will go back to our presentation right now, and I think we have another slide here for Joe. Are you ready for the?
Yeah, I think that pretty much wraps up. Really conscious of time that we've gone a bit over the hour. I was just going to go into a bit of the different packages available. Either Peel3 as just a standalone scanner, or Peel3.cad, where you get the scanner and the software together. But yeah, if anyone's got any particular queries on packages and things like that, then just drop us an email. We can get in touch with a bit more detail there. So I think the next slide just goes into questions, but I think Maria, you've been firing those over to us as they've come in. So do you have any
Exactly. I
more
was.
questions or?
Mhm. No, there are no more questions at the
Okay.
moment.
All right. Well, we'll just leave it a minute or two just in case anyone's got any final questions that they want to ping at us while we're here. Maybe unless they're already available already, do you want to just stick our emails on the chat for in case anyone's got any questions they want to fire over to us after the webinar?
Yeah, I will copy the. Well, we got a question, last question. Can the PL data be exported to use to make a mold?
To,
Make a
yeah,
mold.
to make a
I guess
mold.
it depends. I guess it depends what that workflow looks like. If you can make a mold from the STL, we can take an STL straight from peel.cad, or we can take an STL straight from PLOS. If it's being 3D printed to make a mold, or if you need to make the interfaces for that mold into a CAD model, then it would be a case of extracting those interfaces from peel.cad, bringing them into SolidWorks to create your step or IGES model from there. We can also extract CAD surfaces from peel.cad, so maybe that if you've got kind of complex surfaces that you're trying to model, maybe that's a simpler way of doing it, extracting the CAD surfaces rather than trying to recreate those surfaces from sketches. But yeah, it would really kind of depend on that workflow that goes into creating your mold.
And
Thank you.
depending as well on how complex it's the geometries of the mold, right?
Okay.
But if you've got a part that you particularly want to look at, and depending where you're based, if you're UK based, then feel free to get in touch after. You could send the part over to us in Silverstone. We could do a scan of it and show you the workflow that goes into creating the CAD entities or the CAD faces from there.
Okay, perfect. Well, then, thank you guys for your time and for sharing your expertise with us. We don't have more questions right now. I will put the email addresses of both of you in the chat. So if anyone has any other questions, they can get back to us. And well, thank you again, and I wish you a nice afternoon. Thank you to all the participants as well for your time and your interest. Bye bye.
Thank you. Bye.
Thank you all. Bye bye.